Hello and Assalamualaikum. My name is Syafiqah Alya, BINTI MAZUWINE, and I am from BEEY. My supervisor is Dr. Muhammad Badril bin Nur Shah. So I'm going to present about my project titled The Development of Electrical Control System using Powerline Communication Technology. So this is the contents of the slide, which covers all of these shown. So firstly, the introduction. So, in particular, when the system has a number of control points and switches, the traditional electrical control will require extensive wiring. So this may lead to expensive wiring and maintenance cost. The Powerline communication technology can solve this issue by controlling numerous points with just two wires, which is the live and the neutral wires, in which all points and switches are attached onto the cable. So, to overcome these problems, an electrical control system is designed and developed using Powerline as a medium of communication. The prototype is developed by using two Arduino as the main controller with a pair of KQ330F, the Powerline carrier module, which will act as the transmitter and the receiver of the control system to establish connection through the power line to allow power line transmission. So now we go through the problem statement. So, in traditional wiring, the more the number of control points and switches, such extensive wiring will be required. Then, when extensive wiring is done, it is automatically involving high wiring costs, and soon after it will require higher maintenance costs. Next, the traditional wiring is difficult to be troubleshooted because the type of wiring used in houses is usually concealed, so it will require a lot of troubleshooting work that need to be done. So now, let's move on to the objective and scope. So, the objective of this project is, of course, to design PLC-based electrical control system for home electrical system. Next, the objective of this project is also to verify the efficacy of the developed system so that we can use this technology worldwide. So now, the scope of this project. The scope of this project involves 240-volt single-phase home electrical system, the power line communication, the circuit design, the program development, and the development of the prototype. So now let's move on to the literature review. So, there are several findings connected to the power line communication technology that can be compared for as reference for this project. In one of the many studies by Vishnu, the circuit design has used a PLC modem but includes a PIC and a GSM module. The concept was a PLC-based current theft with device control. The master circuit, which is the transmitter, and the slave circuit are also included. A mathematical model is applied in the program part to calculate the power level of the PIC microcontroller in the circuit to determine whether it is a theft or whether it isn't. So next, a study titled Automatic Meter Reading for Electricity Consumption and Billing System Using PLC, which is suggested by Abhinayam, which is PLC-based electrical monitoring and bill payment system. A new feature was introduced into it compared to the traditional AMR, allowing the user to transmit data to the source. The PLC modem and an RFID reader used in the study enable complete duplex communication, which then allow data transmission to the source. The findings indicate that the home section has been able to contact the main section, which is the transmitter circuit, to allow the payment. And now lastly, the study by Joshen with the title of Automation Using Powerline Communication with Web-Based Access, which includes web-based PLC access control. So this allows the computer to operate as the main controller, which is the transmitter circuit, and the Arduino as the receiver circuit. The PC is linked to the router's wireless LAN network. The research indicates that PLC's reaction time was like 1.5 seconds on average. So now let's move on to the methodology. So this is the components used in order to construct this project, which is the 2-pin plug, the Arduino Uno, the relay module, and the KQ330F PLC module. So this is the main component actually, the PLC module. So now we go on to the circuit design. So there are two circuits in this project, which is the master circuit that acts as the transmitter and the slave circuit, which acts as the receiver. The Arduino will read the input and then send it to the KQ330F PLC module on the master circuit. The module then modulates the frequency and then transmit it through the power line. The KQ330F PLC module on the other end of the whole circuit, which is the slave circuit, will receive the signal transmitted and then send it to the Arduino. The Arduino, as usual, as we all know, will process the instruction and then perform control action to the output device, which is the relay module. The relay module is actually also a switch, but it is electrically driven. The relay module then will be connected to the home appliances such as fan, lamps, switch socket outlet, and more. So next, I'll show you the programming flowchart. So there are two flowcharts, which is for the master circuit and the slave circuit. For the master circuit, the Arduino will always establish connection to the KQ30F, and it will read data from the input interface, which is in this case from the switches. And then the data received from the switches will be sent to the PLC module. Will be sent to this PLC module on the slave circuit. So on the slave circuit, the Arduino will always need to establish connection to the PLC module, and then it will receive the data from the master module, and after that it will perform the control action to the output device. And now the preliminary results. So this is the program code that I have constructed for the master circuit for the Arduino to work with the KQ330F module. This is the program code that I have constructed for the slave circuit for the Arduino to work with the KQ330F module and also the relay module. So, in conclusion, this project will manage to reduce maintenance costs. Well, not only that, it can also simplify wiring installation. This project usually will help to control electrical appliances from a distance. Well, Powerline communication is actually a technology that will benefit towards useful, user-friendly future invention. So this is the Gantt chart for the PSM. So this is my Gantt chart for the future, for the second PSM, which is next semester. So that's all from me. Thank you and have a good day.